Hello, I'm Mike, the crafty physicist, and I'm going to give you just a brief overview of the UK physics degree. Basically what happened, I started putting down ideas of what I want to talk about, and I realised my experiences and opinions about doing that degree would have to play a major role. Then the trouble comes, because I was writing up these ideas, and I realised, here's a definition that no one's going to know unless they really did this stuff. Or here's something that even I can't remember and I did the degree. So I could keep linking to here and over off to the side to somewhere else to get all the sources in. That didn't seem like a good idea. So I've decided just to roll my own. This is a brief overview of the UK physics degree as I see it. To start off, you have three basic choices of degrees that almost everyone picks between. First off, the bachelor's. This is your basic 3-year course. 3 years of physics, exams, lab work, with a piece of longer writing at the end called a dissertation. Second off, you've got the master's. Now, what this is, a postgraduate master's, is after you've got a degree, after you've got your bachelor's, you do another year of work. It's focused on a big long project called the master's project, with some teaching within it. There's also the option of an integrated master's or undergraduate master's. This is basically a 4-year course that combines pretty much the bachelor's with some aspects of the master's. You do exams, lab work, and don't do a dissertation usually. You then, in the 4th year, take a master's project. It's not quite as project focused as the master's if you go in after graduating. I'm going to gloss over the option of doing a degree part-time as well when I talk about this, by the way, because it's similar content but more spread out. That's your sort of 3 main options for how you can do your degree. Next to think about is the choice of style of your physics degree. You can take a degree which is physics, a degree in physics, but you can also, for example, take physics with some subset of physics. So, for example, I did a course that was called Physics with Astrophysics. There's also things like Physics with Theoretical Physics. Basically, these are pretty much the same as your standard physics course, but out of the exams you do, out of the laboratory work you take, and usually out of the either dissertation or, if master's project you do, will be based around that subject. So a physicist who's doing physics with theoretical physics will take more theoretical physics-based courses, likely, than someone who just does an ordinary physics exam. But then they may take less of things that aren't as relevant to a theoretical physicist, so maybe less lab, or less courses in, say, applied physics or sort of biological physics, maybe. Then there are options to mix physics with courses from other departments. So, for example, you can have courses in physics and mathematics, or physics and philosophy. I don't know enough about them to go into them in detail, but in short, your course will be mixed between what those 2 departments want. So a physics and mathematics course will have some exams and some work from the physics department and some from the maths department. And the university will have decided how much physics and how much maths you do to get that joint degree. It will also impact things like your master's project, if you are doing a master's. With that out of the way, let's take a quick tour of what goes on in a physics degree. This is going to be quite vague, because everyone's degree is going to be slightly different, but I hope you'll find something of interest here. First of all, you're going to be introduced to the basics of what you need to do to be a physicist. This is going to take up a lot of your first year, but you'll need the basic maths, so imaginary numbers and matrices and calculus, that sort of thing. You'll also get basic dynamics, Newtonian mechanics, which is going to be the groundwork for a lot of what you're going to be doing. You'll also probably be introduced to basic quantum mechanics, and also a small amount of special relativity, because that's going to be very useful no matter where you are. Again, this is very general stuff that will help you down the line, and you're going to be introduced to it. Towards the end of first year, probably when they've got the mathematical brunt out of the way so you can handle it, specifically calculus involving vectors and multiple variables, you'll start learning about electricity and magnetism, generally leading you on to electricity and magnetism as formulated in Maxwell's equations, which are going to be sort of a vital part of how you think about electricity. You'll also have laboratory work. In first year, there's going to be likely an introduction to some form of data analysis. You will learn how to calculate errors on data and sort of different forms of errors, random errors and systematic errors, and why that's important. A lot of the experiments you do in first year will be fairly simple to carry out, and you'll get good instruction on them. But you'll then be judged on your ability to, say, read outside the basic experiments. This is usually one of the few times where you're going to be tasked with being interviewed. You are likely to have some of your laboratory work examined by someone giving you an interview and asking you to explain your work, how you did it. You will also likely write longer form reports on your lab work. A lab report basically being the thing that's teaching you in future, if you need to, how to write a scientific paper. It won't be of that quality, but it will be working towards that. In second year, you're likely to have a bit more freedom in what you can do. So what I need to tell you is a degree is structured of things like exams, lab work, maybe a bit of essay writing, and the way it worked, at least for me, was you had to get a certain amount of what were called credits each year in courses done. Each course you took and did the exam you got 10 credits for. Each semester of lab was also worth 10 credits. And you ended up preferably with 120 each year. Now, within that, there was a small amount of choice. So you would have some exams that you would have to do, and then some points where it is you have to do an exam. Here are a set of options of courses you can take. Take one of these. And there were certain courses from either in the physics department or in related departments that would be useful for a physicist. You can take their courses for those options. There were rules based on how complex the options were seen to be to make sure someone in, say, fourth year wasn't just taking a first year option to cheat their way into an easy degree. But by and large, you had some freedom here. Now, in first year, most of your courses were taken up by things that you had to do, and out of your options, because you didn't know the basic maths to do them, they were very limited. In second year, this starts to get a bit more free. Because you've done your basic maths work, you can now move on to doing more optional things, applying your physics to more areas. So, in second year, what can you expect to have to do? You're probably going to learn some particle and nuclear physics now that you have the basic quantum mechanics. You may have been slightly introduced to this in first year, but again, without the backing of quantum mechanics, you are limited in what you can do in these areas. You can also expect a subject called solid state physics to turn up, maybe as something you have to do, maybe as an option. And if you took astrophysics, you will expect this to be when you start focusing a bit more on astrophysics, because you can't do astrophysics without basics of Newtonian gravity and a lot of that sort of thing, because otherwise you can't do planetary motion, you can't do a lot of stellar evolution or galaxy formation without knowing that. But now, and more so as the years go on in your degree, you can start focusing on that. Laboratory work, the experiments now get more complex and the amount of instruction you receive to help you do them will become more limited. Basically, when you start, you are given a lot more information to help you complete the experiment. As the years go by, you could say you'll be given more freedom to do it the way you want. You could say you're just being given less information. Either way, it's now challenging your ability to research a lot more. Also, laboratory reports are slowly becoming higher in standard. You're expected to write more, you're expected to write in better quality. Whereas first year, a lot of it was spent making sure you just get basic formats right, making sure you're using references correctly, that sort of thing. Now you are really going to be pushed on detail. From this point, I can basically no longer help you. The third year of a physics degree is going to be incredibly varied depending on what you want to do and what area you want to go into. You've got laser physics, you've got general relativity, galaxy formation or something like that. You've got an enormous array of options. I said before that in first and second year, a lot of what you could do is what you had to do. It was blocked up. There were exams you had to take and then a small amount of optional courses that you could do. Now things are going to be set up a bit differently. You've got a lot of options. You've got a lot of things that you can do or you can choose between different courses, and a lot less these are courses you have to do. If you are doing a 3-year bachelor's, this is when you'll do your dissertation. It's basically a longer piece of writing about a subject in physics. Since I didn't do one, I don't want to talk too much detail about it in case I get it completely wrong. But that's the long and short of it. It's a very important piece of work, and consider that this bit of writing is usually weighted so that it is worth at least, say, 2 courses of exams. Given each course of exams is lectures for 1 semester or half of the university year with a big exam at the end. Consider at least 2 of them as a good idea to give you a ballpark of how much work is expected to be done on it. If you're going on to an undergraduate master's, you will be now doing probably extra lab or extra exam courses to make up for the fact that you're not doing a dissertation. Now, for those of us who are going on to 4th year, for an integrated master's, you'll be doing usually either 1 or 2 master's projects. Think of how I talked about the dissertation earlier. Again, these are worth multiple exams in terms of how they're weighted. They're going to be a large scientific project this time, involving you doing experiments and then writing them up. Unlike in earlier labs as well, it's likely that the answers for what you're finding out aren't already known. And actually quite a few people end up doing a PhD that pretty much follows on from the work that their master's was in. If you're doing a postgraduate master's, things are pretty similar here, but the weight for the research portion of your degree is going to be far more. An undergraduate master's and postgraduate master's will likely take some taught courses during their time, but the undergraduate will take a lot more and will have less weight put towards their project. The masters will have someone called a supervisor. Essentially, they are an experienced researcher whose job it is to sort of guide you through it and give you help and advice and then judge you harshly. At the end of all this, you get a degree in physics, or 2 if you did bachelor's, then postgraduate masters. Basically, you get marked for each part of the course. So in an exam, you get, say, 70% of the questions right, 70% or 50% or 10%, and you fail miserably. Those are all added up, averaged, and your degree grade is given depending on what this average is. So say above the percentage, you get first, between you get a 2-1, and then a 2-2, and then a third, and then we just give up. Sometimes, if you're right on the border, generally between a first and a 2-1, there is an interview called the Viva, where you basically get one last chance to push yourself to a first. With that out of the way, you get a degree. Go you. You get to prance down the aisle in stupid clothes, and someone gives you a bit of paper. And that's it. Now you gotta go get a job. I've been Mike, crafty physicist, and that was roughly what happens in a physics degree.